Okay, so now we are doing the another unemployment model. This is called the Diamond Mortensen Pissarides model, DMP for short. So in this model, we have n number of consumers, and these are all working age populations, so like potential workers. Okay, um, cool. So of those n, you can either be in the labor force or you can be not in the labor force. If you're in the labor force, the letter we'll be using is a Q. If you're not in the labor force, it's just gonna be like n minus Q, like just like the opposite of Q. And so these could be people that are working like outside. I have no idea what that means, but like another example is like stay-at-home parents or whatever. Or I guess if you're students. So next, we have like a basic curve to like sort of like demonstrate the idea of why people work, kind of, I guess. So we have like this chart here with Q at the bottom, and then there's V as a function of Q, where V means value, and this is like the value of being in the labor force, of being a part of Q. So it's like the payoff for choosing to search for work, and this VQ is different for each person. Like I might have like VQ, I guess it's sort of like a so it's like a value, okay, so it's like the value that you get from being from like searching for work. So I guess it's different for each person. Like I might not care too much about the unemployment benefits, but like somebody else might care a lot about those. But whatever, anyway, it's different for each people, so it's like an upwards curve like this, and it increases because as V increases, as the value of being in the labor force increases, more people are going to want to be in the labor force. So the Q will increase as a function of that. And so like an upward sloping curve, blah, blah. Okay. Next, so we have like basically, or those consumers, right? Or sounds, oh, damn. Okay, so now we're going to look at the firms. So these firms will post vacancies, so they're going to put up like job posts. But these things cost K, like to like host them on like different websites or whatever, in order to hire people. So the thing is, firms that don't post vacancies are inactive and they can't produce, which basically means that they're no longer a firm basically. So I guess in order to be a firm, you have to like post vacancies. So you have to pay this cost to be like a firm thingy. And so the number of active firms, so the number of firms that post vacancies is denoted by the letter A. And again, by like when we say that, since we have like this condition that firms that don't post vacancies can't produce, that means that A is sort of like basically just like all the firms there are, I guess, or else like they'd be just be like dead kind of. So yeah, so we have like two letters so far. Q is a number of people in the labor force, and A is a number of firms that are looking for people. So now we're gonna go over to the matching principle, like not principle, matching idea. So there are Q customers, or like Q like people, like potential workers looking for work. There are A firms looking for workers. So now there's like a person over here who's like a Q, and they're like, oh my god, look, there's a job posting. Ah, and then they're gonna go and join that company. Okay, so there's like a really big lag in this thing. So from now on, I'm gonna make the purple coloring come before I speak, or it's gonna be a bit odd, but whatever it is, what it is. So there's a matching function that they give, and it is M equals EMQA. So big M is a number of matches, like just like the total number of matches, like overall. It's not like a rate or anything. That's just like the number of matches, like I don't know, 357 matches, etc. Q is the number of people, like number of workers. A is the number of firms. E is this thing called a matching efficiency. So I guess it's like how easy it is for people to like match stuff. I don't know. This might be improved by like technology, maybe. Like if you have like better technological processes that can like determine which, I don't know, employee is best suited for your job and like find people like that. I don't know. But something like that, matching efficiency. M over here is just like it looks weird because I use the letter M, but it's sort of just like F, like the letter F and then QA. Like it's just a normal like a function, except it's just they're using the letter M because it makes more sense because like matching M kind of thing. So this isn't like a variable or anything, it's just like the function letter. Okay. Next, so we have some properties for this function M, so the MQA thing, not like the big M but the little m. So first it has constant rate of substitution. So if you were to multiply the A and the Q by some amount, like if you were to multiply the number of workers and the number of firms both by 2, then the total number of matches will also increase by 2. So it's going to be like bringing it outside. This is for like multiplication greater than 0. Next is if A equals 0 or Q equals 0, M equals 0. So this is just like in this function, like if there were absolutely no, let's say you had like 10 firms looking for people and you had like 0 people looking for work, then none of those 10 firms are going to be able to find anybody because they're like, oh, look, there's nobody looking for work. So like the total number of matches would be 0. So that's how this thing works. This is more like, whatever. This is just like sort of like dependent on the actual function. Like this thing, like this A, if A equals 0 or Q equals 0, M equals 0, applies only to this function. Like it's not like a normal thing or anything like that. And third is if either A increases or Q increases, then the total number of matches increases. Now you might be like, well, what if we have like, I don't know, one company, so like 1A, and then we have 3, 3Q, and then the Q increases. How the hell would that increase a match? Like, shouldn't it be like if maybe the smaller number increases or whatever? Well, let's imagine that each of the 3 workers are all like not applicable to the actual company that's looking for the work. So the company's looking for like, the company's like a computer software developer. They're looking for like a developer, I guess. And these 3 guys here are cooks, accountants, and lawyers, and they're like, bro, we don't need you guys. So in this case, it's like the total M is 0 because there's no proper worker. But then here you get this new guy, this new software developer, and like the Q is now equal to 4, and now the matches is equal to 1. And so because of that, like just like increasing any number will increase the number of matches. And fourth is the idea of diminishing marginal product. So the increase in the total number of matches is smaller if Q or A is higher. Increase in is smaller if Q or A is higher. I don't know what this means. I think this means like if Q or A is higher. Maybe it means something like in this example over here, we use like smaller numbers like 3 plus 1 is 4. But maybe they mean something like if you have like one firm, oh crap, this is like, if you have like one firm and you have 286 people and then you have 287 people, the increase in M, if Q or A is higher, I don't, okay, diminishing marginal product means that as something increases, like the marginal product, like the value which kind of you get from it decreases. So in this case, basically as something increases, the number of matches that you get from it decreases. How could that be though? Like, shouldn't it be the opposite way? Like it literally says if A or Q, increase in M. Okay, this is the increase in M is smaller if Q or A is higher. Okay, so I guess they mean something like, let's say if A and Q, like A is 3, Q is 3, and the matches is, let's say, I don't know, like 2. Yeah, let's say A equals 280, Q equals 287, and then matches equals like, I don't know, 250. And then let's say from like, increase in M is smaller if Q or A is higher. Okay, they mean increase in M. It's like a little marginal product. So maybe by like, they're saying like by increasing one more Q to 290 and just keeping this at 280, this might not increase the matches by so much. Probably. I don't know. I think that's what they mean. I don't think we need to worry about too much about this, so let's not think too much about it. So let's not think too much about it. So next we're going to look over the idea of consumer optimization. So first of all, if consumers join the labor force, so if they become a part of Q, they have 2 options. They either get a job and then they earn a wage of W, or they don't get a job, but they get the EI benefits of B. Now the probability of finding a job is, for consumers, we're going to use the letter C, denote the letter C. So it's PC equals the total number of matches over the total number of consumers. So just like probability, like the total, okay, cool. Now matches functions we know is EMQA over Q, EMQA from that first thingy. So, and then dividing that by Q, we have this. And since we have constant rate of substitution, we can sort of like delete these 2 things. So we can like divide both the top and the bottom by Q. Is that how it works? Yeah, whatever, divide them all by Q. So now we get EM1 and then A over Q as our new probability of consumers finding a job function. Now we're going to set a letter J equal to A over Q. And it's okay, so A, because I have to remember this thing. A is, what is A again? The total number of firms. Q is the total number of people. This is called a labor market tightness. Labor market tightness. Oh my god, how tight is a market? It's like, it's let's say if J increases. If J increases, then I'd say, oh my god, it's like the market is getting tighter, which means that A is greater than Q. There are more firms and less workers, which means that firms are fighting for the workers. Okay? Right? Labor market tightness. So when you say like the market is tight, whatever, we gotta imagine ourselves as like a big corporate snob. I mean, a big corporate person sitting in like a little seat, looking for like trying to find workers to work for us, and us thinking, damn, the market is so tight. Like, how am I supposed to find all these workers? There's only so less workers. And so basically, okay, basically the J, the labor market tightness, is A over Q. Okay, cool. So you can just substitute that into this. It's A over Q because remember, if J were to increase, I as a corporate person would think, oh my god, we have. What would I think? As a corporate person, I would think, oh my god, there's no people to work for me at all, which means that Q would be decreasing and A is increasing. So it has to be A over Q, not Q over A. Okay. So yeah, so we can sort of do this. So this is like our new like function for like probability of consumers finding a job. It's EM1 comma J. Now the probability of being unemployed is just 1 minus the probability of getting a job, which is 1 minus EM1 over J. Cool. So the value of being part of the labor force, of being part of Q, is the benefit of searching for a job. So this includes both the benefit of what you get once you get the job and plus any EI benefits that you get while you're looking for the job. So VQ is the total probability of finding the job times the wage that you get, plus 1 minus the probability that you get the job, so like the probability that you don't get the job, times the EI benefit. Now we're gonna, rearrange this and blah blah blah. Okay, actually I'm gonna do that right now. So we have PCW plus B minus PCB. So right now we're gonna write this PCW minus B plus B. So this is going to be another version of our total value curve for the consumers, okay, of being in the labor force. And we know that PC is our whole EM1J. So this is W minus B plus B. So this is our value function. Cool, cool, cool. And yeah, so that's that. So that's just like it's like a function that we'll be using. And remember this function, which, oh wait, did I already do this? Yeah, I did, remember? This function again is upward sloping, so it's like this. Okay, cool. Now we're gonna look at firm optimization. So before we did was consumer, now it's firms. So for the firms, what they're gonna be doing is they're gonna be looking for workers. So the letter we're gonna be using is PF for P firm, the probability for the firm. So this is the probability of the firm finding a worker. So PF is the number of matches over A. Remember before it was a number of matches over Q because it's like, how many people find a match all over the total number of workers, whereas now it's M over A. So M is EMQA over A, and again with the whole constant rate of substitution, we can just divide these two A's. So it's Q over A and then 1. And remember A over Q is J, which means that Q over A is 1 over J. This means that this PF is equal to EM 1 over J, comma 1. Now, another thing to remember is that these firms have to pay K, to like find these jobs. And then they produce output Z. This is just like a letter, like this is how much like each person produces. Like each of their workers produces this much Z, okay? Now the profit that they receive per worker is Z minus W. So like each worker produces like this much of like stuff, and we have to pay them like a wage of W. So another thing that we have is that there's free entry for firms. So this is like, what's that thing called? Perfect competition or whatever. In a perfect competition, we know that the total profit at the end that the firm receives is 0, which really sucks because then it's like, why would you even join, you know, if you're not even making a profit? So now what we're going to be looking at is looking at the total profit and equating that to 0. So first of all, profit equals the probability that they get a worker times the profit that they get per worker minus the K that they had to pay for that person. Remember? To put out posting, they had to pay a person. You know what I don't kind of understand? Why this K isn't in this thingy? Like, probably, okay, no, I guess it's like, no, never mind, I was dumb. I'm sorry, I was dumb. You have to pay K no matter whether you actually get a person or not. So this K wouldn't really fall under like the probability of finding a worker part, okay? So just like probability of finding a worker, Z minus W minus K equals 0. Rearrange this, substitute EM1 or J1 inside the PF function, and we get K over Z minus W. Cool. So now a cool thing here is that we have PF equals K over Z minus W. Nice. Okay, let's see. Blah, blah, blah. Okay, sure. So I made a note here that J is determined by these values. So like J is determined by K, Z, and W. And if like any of these things changes, then J would change. And like that's true. I just want to like see if there's anything else I can like. Obviously, there's other things that can change J, right? Other than K, Z, and W. Like for example, B. Like in the consumer function, if B changes, then J would change. But yeah, like for some reason, I just written that down. Okay, so equilibrium is the Nash bargaining solution. I don't actually remember anything about the Nash bargaining solution. I know that decision tree thingy, but I'm not really sure how it applies here. But what we're going to do is we're going to look at surpluses, okay? The worker surplus, like the worker sort of like benefit, you would say, of like, you know, getting that job is going to be, okay, by worker surplus, sort of like, this is sort of like the benefit of getting the job, okay, versus like just being in the labor market, is W minus B, like, you know, first they got B when they were like unemployed, but they were looking for a job. And now they get a job, they get W. So it's like, yay, I get W minus B. Like that's, like they get W, but like, you know, so like an overall benefit-ish is W minus B. Is that clear? I think so. I think it is. Next, we have the firm surplus. So the firm surplus is that whole Z minus W thing. Remember the firm's profit that they get per person. Oh yeah, okay, so surplus, I mean like in this case, sort of just like profit. So it's like profit per person is Z minus W. And for the worker, their profit-ish is like W minus B. So let's see, because they're giving up, by working, they're choosing to give up this like EI benefit that they would have received from the government. So the total surplus is the sum of these two, which is Z minus B. Now the worker's bargaining power, we're going to denote by the letter A, whereas A is between 0 and 1. The firm's bargaining power, thus, I mean, as a result, is 1 minus A. Cool. Now, what we can do is, since workers' bargaining power is A, we can just write that workers' surplus is A times like this bargaining power times the total surplus. So it's A times Z minus B. So, oh crap, oh no, did this thing stop? Okay, it's, oh no, what did I do? Whatever. It's frozen. This is great. Okay, it's A times Z minus B, and that is a worker's surplus. And the worker's surplus is W minus B, and we can rearrange this to get W equals AZ plus 1 minus AB. So like by just like bringing the B to the other side and like all, you know, like combining like terms and all that stuff. Cool. So now, okay, you know what? Am I actually learning here? Not really. Let's go again. So we have W equals AZ minus AB plus B equals AZ plus 1 minus AB. So now what we, okay, so we've gotten to this part. So now we're just going to sub this into the consumer function. And of like the B plus EM1J a W minus B. Wait, we did not have W minus B. Is that what we had before? B plus, I'm taking a video by making a video. Okay, so before this thing, what we had was W minus B, which I don't actually remember. We had W minus B? What? When did we ever come up with that? Literally, when did we ever come up with that? Okay, but like, okay, so I guess I never really explained that, I guess. Oh yeah, I never explained that. Okay, so this value function, what the hell? Okay, whatever. This value function is broken up into two parts. The value of being unemployed, you would get B, plus if you were employed, you would get, you know, like this is like the probability of being employed times that like sort of benefit that you get, like the sort of like profit that you get from being employed, which is W minus B. So that's how you gotta remember this equation. So W minus B is the same thing as A Z minus B, so we sub that in here, and we get this thing. That's great. Now the firm function again was EM 1 over J comma 1 equals, okay, I do not remember this, like I literally only remember this one VQ, right? Okay, like I remember the consumer function, but this firm function, there was like this two other stuff. I mean, what? What? Let's go again, because I do not remember this. Is it firm optimization maybe? Okay, so the probability for the firm to get a person thingy is EM 1 over J comma 1. Okay, cool. Now we're going to look at the total profit that the firm gets, which is equal to 0 because it's free entry. So we get that the PF times Z minus W, so the profit that they pay minus K equals 0. We rearrange this and we get PF equals K over Z minus W. And we also have PF equals this thingy, so we have this thingy, this EM blah blah, is equal to this K Z minus W. And both of these are equal to PF. Like there's like different versions of writing PF, the PF function, okay? Cool, cool, cool. So now, so now we have K over Z minus W. So probability PF equals K over Z minus W. You don't remember that? Okay, PF, probability for the firm, is equal to the cost that they pay to put up a posting, cost for post, all over the profit that they get from each posting, kind of, in a way. And that is apparently called the probability. So if I have the cost minus, divided by the profit, that's sort of like a, I don't even know what that is, like I don't even know what that is. Like I don't even know how to think of that. Whatever. So then it's an odd way. You know, I've thought about this enough, so I feel like I remember it. But anyway, so we have this K over Z minus W, and from here, we have that Z minus W is equal to, Z minus W, so the thing is, since worker surplus, from here we have W minus B, so worker surplus equals A Z minus B. We now know that firm surplus, by like using the same idea, is going to be 1 minus A times Z minus B, like this. 1 minus A, the firm's bargaining power, times the total surplus. So it's just 1 minus A times Z minus B, and that's what we're doing right here. It's 1 minus A times Z minus B, instead of the Z minus W thing here. Okay, so this is basically like our new sort of firm function, so we can sort of, I'm just going to make a little firm thing here, just to remind us. Cool, cool, cool. So basically, okay, so the thing is, for the consumer, there's only one, like, P consumer, like PC. PC equals EM J and then comma 1, whereas for the firms, there is both K over Z minus W and the EM part, because like there's also like the worry about the profit thingy. Okay, Cool, cool. So now we have to find the equilibrium. So in order to find the equilibrium for anything, we would first use the second function, so this em 1 over j blah blah function, to find the new j, like to see if j increased or decreased or whatever. And then we plug that j into this vq function to find out the value and then find out the q. So the thing is, the v and the q function are kind of weird because it's sort of like v is a function of q, but like you have to find out the value first, like the value of, you know, being a labor force first in order to find out how many people are going to be like, that's a good enough value, I'll join. It's just like something you have to like think about, I guess. I mean, not really, you don't have to worry about it too much. Just like first you find v, then you have to like from there you find q. Okay. So this is like, okay. So this is like a little like a picture of what the equilibrium would look like. So this is using the second function, where it would be like, this is the em 1 over j1 function as a and where j is on the x-axis, and then this point intersects the point at like the equal j, and at that point we have k over 1 minus a z minus b. So remember, these two are both pf functions. Equals pf, and this equals pf. Cool. And they're all like equal and stuff. So basically, once you get that, you go down to the letter j, and you're gonna go up to the function, and when you go to the right, that is where your q is. This function here is a consumer value function, and we'll be using, this case, we'll be using the a z minus b thingy instead of like the w minus b. So just some rates that we have to worry about, not like worry about, like just like they might ask you guys like, oh, like is there any change to the unemployment rate, or is there any change to the blah blah? Is the unemployment rate, which is the unemployed over labor force. Unemployed are people who are in the labor force, so Q, times the people who are unlucky enough to not be a part of that PC, the probability of people who found a job. So that's divided by Q, again, for like the labor force, total labor force is Q. This equals to a total of 1 minus PC. PC is EMJ1, so that is this is that. So the vacancy rate is the unfulfilled job. So this is total unfulfilled jobs, which is what are total unfulfilled jobs over the total jobs posted. So the total jobs posted is like the total number of like active firms, so it's A. And the unfulfilled jobs is A times 1 minus the probability that the firm gets a job. So like all the unlucky people who weren't able to find a worker. So this is just 1 minus PF. PF is 1 over j comma 1. So this is the vacancy rate. And then we have aggregate output. So aggregate output is like the total amount of stuff that is made. So that is the total number of matches, because the matches represents like how many people are working, kind of basically like they have a job. So the people who are working times the amount of product, the amount of output that each of those people produces. So M equals EMQA, and then we would multiply that by Z, and we can take the Q out. So we get 1, and then basically like divided by Q, and then divided by Q, so we get 1, and then A over Q, which is J. We just bring this Q out. So one thing that I made a mistake with is I accidentally, when I was writing this part out over here, this EMQA, I accidentally wrote it as Q and then like 1. I mean like 1 and then J or whatever. Yeah, I wrote it as Q and then 1, I think. Yeah. Because I totally forgot that like, because like PF, I totally forgot those like sort of take into consideration, like they like divide it by Q, right? Or they divide it by A. And I totally forgot about that in the remember, whatever, I just forgot the matching function. So you gotta remember the matching function. It's EM Q over A. And it's only after dividing by Q and dividing by A that you get like this little J and 1 thingy. So now we have experiments. Experiments are basically just like what happens if, I don't know, B increases, etc., etc. So first, oh my god. So first one is what happens if B increases. So B is the EI benefit, and just like from logic, if the BI benefit increases, more people are going to join the labor force, so there's going to be more Q. So just like, this sort of like logic, just like something to keep in mind. So first we look at this graph, and this graph is basically a J compared, this is the firm graph, okay? So we have the firm PF function of EM 1 over J comma 1, and then we have like these y-intercepts of K and 1 minus A, Z minus B. So B increased, so B increased So over here, z minus b decreased. So this whole k thingy increased. Just like, like mathematical logic stuff, whatever. Which means if this increased, this went like this, and we move along the curve, so j decreases. So j moves this way. And now we're going to use that in our new function, and our function over here. And so this function over here is j and then q, and we have like this vq function. And so original we have j1 and then q1, and then we have some changes that occur. So one is that b increases, so basically this b over here increases, and then we have that j decreases over here, like from the first function j decreases. Like b increasing is like the original effect, and then j decreasing is like a subsequent effect. So we have to think about both of those. So since b increases, this guy over here increases. If this guy increases, then this guy decreases, and j decreases, so this whole thing decreases. So there's like a lot of different changes going on, right? Which is why there's like, we don't really know how to draw it. I mean, we don't really know like what the actual effect is going to be. But one thing that we're going to do is we're going to remember that since since j decreased, and like since this whole like sort of part decreased, we're going to basically like reduce, like sort of like make this function go lower. What the hell? What? Why is it going the other way around? J1, B1. What? I'm confused. Oh, okay, you know what? No, my bad, I think. First, we're just going to think about the fact that B increased. So since B increased, we're going to have an upward shift in this VQ curve, okay? Like an upward sort of like tilt-ish, the VQ curve. What happened to J? I'm kind of confused here. I don't, if J decreases, so this entire thing, did I draw this correctly? Sorry, I'm gonna have to quickly do something. I don't know if it's gonna stop the recording. Increase in B. The thing goes up. Okay, you know what? I think it's just like in the graph, they drew the thing to go up just because like, you know how it's like we'll learn that it's ambiguous basically, so like it doesn't really matter which way you draw it as long as you tell them like it's ambiguous. I just happen to draw it going upwards, I think. Hold on, let me see. They're saying that there is a shift up in the VQ curve. Basically, they're saying like no matter what, there is a shift up in the VQ curve. Okay, so there is a shift up in the VQ curve because of this increase in B. But the thing is, there's also this increase in B, and due to this increase in B, total value, and due to this increase in B, Z minus, if B increases, Z minus B decreases, so this entire thing decreases. But I guess it's like, since there's A over here, which is like, oh crap, what the hell did I do? Since the A over here is like from 0 to 1, that means that this decrease in the B has no effect on like this increase in the B. So like this guy is like ultimate, whereas this guy's sort of like an extra effect. So because of that, there's going to be an increase in the VQ function, okay, nevertheless. So first we draw the VQ function upwards, and then we're like, oh, there's a J decreasing, so we first, draw the curve. First we have our J1, and then we have draw our second curve, and the J2 is at a lower point, and then we get like our Q2. Now, what we are confused about though is about Q, like is Q decreasing or Q increasing? So first of all, we know that J decreases. Second of all, with VQ equals B plus EM blah blah, so the thing is, J decreases, and so because of that, the whole EMJ thing decreases, so VQ decreases. Is there anything else? Right, and since VQ decreases, Q decreases. And second thing is that we have B increasing, So because of that, we have V as a function of Q increasing, so Q increases. So I don't really know why, like, are we not talking about this B over here? Like, what happened to this guy over here? Like, we're just gonna ignore him? Apparently. Apparently so. So let's just forget about that guy. So why are we gonna forget about that guy? Because there's a bigger B over here, and we're gonna worry more about this bigger B, this more important B, okay? So because of that, since there's an increase in Q and also a decrease in Q, we're gonna say that Q is ambiguous. So now we're gonna look at Y. So output Y equals M times Z equals EMQAZ equals QEUM and all that entire function, blah blah blah. And we know that J decreases, so this thing decreases. But thing is, since Q is ambiguous, we don't really know if it's gonna go up or down. We can't actually say anything about Y, so Y is also gonna be ambiguous. Now for the unemployment rate. So your unemployment is U over LF. U is people who are in labor force who do not get the probability of finding a job, 1 minus PC, times Q, so it's equal to 1 minus PC, equals 1 minus EM J comma 1. And here we know that J decreases, so 1 minus E and blah blah blah, and this entire thing increases, I can't even see. J decreases, so this thing increases, so because of the unemployment rate increases. And then next we're going to look at the vacancy rate. So the vacancy rate is the unfilled jobs over the total firms that are total firms with jobs posted. So that is A times P, 1 minus PF over A equals minus PF equals 1 minus the whole matching function thingy. So here we have J decreasing, so because of that 1 minus J increases, so this EM thing increases. Right, so 1 minus EM thingy decreases. Cool. So that is the total, like, effect sort of thing of an increase in B, I think. Yeah, an increase in B. So now we're going to look at an increase in Z. So first of all, we first draw out the whole function. And we have, like, J, we have the EM for the firm function, 1 over J comma 1. We have our original, K function, like this K y-intercept kind of, I mean. Well, actually, oh wait, it's not actually a y-intercept, it's just like a point. Yeah, so this thingy. So first we have an increase in Z, which means that this Z over here increases. Okay? So what we have right now is that, the Z minus B increases. So K over Z minus B decreases. So this thingy decreases, so that, like, this whole, like, thingy decreases, and we basically get to a higher J, so J increases. And my throat is becoming dry. So next, oh my gosh, this is so long, literally so long. I will never watch this. Let's hope I've learned enough for making this video. So next, we're going to look at this from the consumer's perspective. So we have our J and we have our Q and we have our function. So first, what do they tell us again? They told us Z, ouch, Z increased, which means that the VQ function has to increase because, like, this Z over here, this Z over here increases, and I hate that the marker doesn't, yeah, so this Z over here increases, so the entire VQ function increases, and so because of that, what we have here, and since we have that J increases from this original thingy, we have to move to the left side, blah, 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 and draw this new J point on the new curve. So we have this new Q2. That is cool. So now we are going to look at we're going to look at the effect on all these thingies. So first, let's look at the effect of J. So J, we know, increases. Next, Q, also Q. First of all, since Z increases, we have the VQ increases, so Q increases. We also know that J increases, so the EMJ1 increases, so Q increases. So both the effects lead to Q increasing, so the net effect is that Q increases. So Y equals MZ equals EMQAZ equals QEM blah blah blah, etc., etc. We know that Z increases, that's your, like, original thingy. We also know that J increases. That is also like one of the like subsequent effects. And then we know that Q increases, which we just learned. So all of them lead to Y increasing. So it's great, whatever. So next we look at the unemployment rate. That's unemployed over labor force. Q times 1 is PC over Q. Blah, blah, blah. We have J increasing. And if J increasing, then this thing increases, which means that 1 minus this thing decreases. So the U rate, the unemployment rate decreases. So next we have the unfulfilled rate, or whatever. Oh my god, it's the vacancy rate. Whatever, I just changed the name. Which means unfulfilled posts over the total posts, like the total like number of job postings. Blah blah equals 1 minus probability of the firm is 1 minus EM 1 over J comma 1. So since J increases, this 1 over J decreases. And since the 1 over J decreases, the EM function decreases. So the 1 over EM function increases, which means that the vacancy rate increases. Great. That's our second like thing that we're gonna be looking at. And third is a decrease in E. So one thing that you may have noticed in these two, in the prior two things, is that the first graph that we looked at never moved. It was only like a movement along the actual curve. And why is that? Because, well, I don't actually know. Okay, I'm just gonna use an example. So when we have like demand and supply curves, let's say this is our demand, supply, and this is like our price, and this is our quantity or whatever. Whenever there's a change in the price, it's always just a movement along the curve. And it's only ever if there's a change in the actual demand, like number of people, like number of like the actual like, I don't know, consumer interest, whatever. It's only if there's a change in that the actual curve shifts. So basically like only if there's only a change in like all the things that make up this demand that change, then the curve will actually change too. Oh my god, what the hell happened? Where do they all go? Okay, I'm going to, I don't know, actually. What the hell? Oh, there we go. I see it. Oh, there we go. I don't know where they all went. Okay, so yeah, so the thing is the demand and supply curve. So basically, in this example, in the prior two examples, the only things that changed were like the values that were on like the side of the graph, like in like the K, A, or Z, or B, whatever. Those are the only things that changed. And so because of that, there was like no actual change in the actual curve. But in this case, they were saying that the actual E changes, so that the whole efficiency thingy, the matching efficiency changes. And so since the thing that's making up this function is actually changing, there will be a change in the actual function. So it decreases, so we're going to move the thing to the left. And there are no changes in any of these things, K, A, Z, B, so this will stay constant. So it's just like a decrease in J, basically. So now we are going to draw out a new graph. So in this thing, what we have is E increasing, so VQ decreases. And we also have that J decreases, so VQ decreases. So like an overall effect is like a downward shift in the VQ function. And an overall effect and blah blah comparing to this new J2, we get that the Q decreases. So now to look over this stuff. So overall effect is that J decreases, and then we also have Q decreases. This is because both E and J decrease. So like in the value of Q function, the value of Q function has to fall. Third is we have Y equals MZ equals EMQAZ blah blah, and that whole thing. So since E decreases, J decreases, and Q decreases, so Y has to decrease. Next, the unemployment rate is U over LF equals 1 minus PC. In this case, E decreases and J decreases, so this means that this unemployment rate will increase. And finally, the vacancy rate, 1 minus EM 1 over J comma 1. So we have that E decreases. So we have that E decreases, which means that the vacancy rate would have to fall since this entire thing. Wait, hold up. Yeah, wait. If this thingy falls, if E decreases, then 1 minus E is smaller, right? Okay. What? Wait, no, shouldn't it? Wait, shouldn't it this? What? It should be increasing actually. Oh, okay, I actually wrote this wrong. Oh yeah, it makes sense actually because I wrote this wrong. This is actually supposed to be an increase in the vacancy rate since the E decreases. And another thing we have is that J decreases, so 1 over J increases, so this whole EM thingy increases, so the vacancy rate falls. So we're going to be like, oh, the vacancy rate is ambiguous. However, the answer is going to be no. Because, I mean, not no. It's just like, basically it's that EM 1 over J comma 1 is that firm function, that probability of the firm equals EM 1 over J 1. But this thing is also equal to the whole, oh crap, no. K over Z minus W over K over 1 minus A times Z minus B thing. And since none of these things changed, there basically is, since this thingy equals this thingy, and none of these things changed, then this thingy is basically like, sort of like, it's constant. There's no change. So the vacancy rate is constant. Yay, that's it.